Okay, so today we are going to graph linear inequalities. Before we can do that, I just want to go over and make sure that we remember how to graph a line. So you're going to start at your y-intercept of 6. You put a dot right here. And then your slope is 1/2. That means you're going to rise 1 and run to the right 2. The other way you could do that is you could just reverse both directions. You could go down 1, but then to the left 2. So if you're going to reverse one direction, you have to reverse both of them. And then you just draw a line straight up, just like that. Okay, so same thing here. We're going to start at 4. We're going to count down 3 and right 1. Here's your slope, and you're just going to connect them. And then if you don't see any numbers, you have to remember that there's a 1/1 in front of the x, and there's going to be a y-intercept of 0. So we're going to start at 0. We're going to go down 1, right 1, and then we're just going to connect those. So it's a nice perfect diagonal straight through the origin. So we want to make sure that we can graph lines, because the next thing we do is going to involve something that you might have to change about your lines, and then we have to do some shading. So the first thing we want to make sure is how to pronounce this kind of symbol. So if you see Y and then that symbol, that is the less than symbol. So that means you're going to shade below your line. So think less than means lower, beneath, under. That's why we shade below. And then greater than is obviously opposite. So if you see the greater than symbol, you're going to shade above the line. So you have to know at this level which symbol is less than and which symbol is greater than. That we have to know. If you struggle with remembering that, a little trick that I've always used is the less than symbol actually kind of looks like an L. So L for less. If you recall from Algebra 1 days, if it's not underlined, that means you use a dashed line. All right, so if it doesn't have an underline, it's considered not inclusive, and the way that we show that is with a dashed line. So what I want you to do is we're going to go back to A through C, and I just want to change this equal sign for A into the less than or equal to sign. We're going to change B into the greater than symbol, and we're going to change C into the greater or equal to symbol. Now you'll notice your lines are not going to change. The only thing that you're going to have to do is, because letter B is not underlined, you're going to have to make this into a dashed line. So that's where you just take your pencil and just erase sections of the line, make it look dashed. And then this line right here is going to stay the same, so a nice solid line. Now normally when it said equals, we were done. We're not done in this case, and it's because of just a logical kind of thing. If I ask you to figure out what goes in that space to make this equation true, most people are going to say 3. And it is 3. 3 is the only number that will work. But if I change this to a greater than symbol, for example, I could plug in 5. Now I would get 6. 6 is more than 4, so 5 would work, 6 would work, 7 would work, 8 would work, and so on, right? Lots and lots of answers. So all I need to do is make sure that my y value is less or equal to whatever I get on the other side. So there's going to be a lot of solutions to that. The way you show that is by shading. So the shading is always interesting. We have kids that can just look and know what below and above means. They can see it, and then there's other students that just can't see it. There's some kind of barrier between their ability to visualize and interpret a graph. So one thing you could always do is you want to take your pencil and you just put it kind of in the middle of your line. Right here is good. And if it says less, you're just going to lower your pencil a little bit. It doesn't have to be a lot. All right, any amount's fine. And you're just going to start a little fire. And just like out in the real world, if you have a wildfire, it tends to spread. So you just want to spread that fire around. Just like that. And so what that means is that any point in that shaded region will count as a solution. If you plug those numbers in for x and y, it's going to be a true statement. So we'll do the same thing for letter B. We're going to take our pencil, we're going to put it in the middle, Now this says greater than, so you're going to raise your pencil up a little bit and start a little fire. And you just let that fire spread. Okay, we do it one more time. Again, this is a greater than symbol, so we put our pencil on our line and we raise our pencil up for greater a little bit, and then we just spread a fire. So if you struggle with the whole shading thing, that's a technique that you could always use. You could just put your finger on the line and decide, should I move my finger up or down? Up for greater, down for lower or less. So I just want to do a couple follow-up questions for letter A. I want to know, is 2, 1 a solution? So the first thing you want to do is find it. 2, 1 is right here. And you see how that's in the shaded region? Then we're going to go ahead and say yes. Why? Because it's in the shaded region. Now if I ask you about -4, 4, that is right here. Now that's actually on the line itself. So some kids say, no, it's not a solution because it's not in the shaded region. Other kids say, yes, it is a solution. The kids that would say yes would be correct. It is a solution, and the reason why is it's on the solid line. It is touching the shaded region, but the line is solid. So then we are going to count it. And we're going to do it again, but this time with graph B. Get rid of my dots right here. All right, so 0, 4, that is right here. Okay, now you'll notice that is on the line, but this time the line is dashed. So that means we cannot count points on the line as answers. So no. Why? Because it's on a dashed line. And then 1, -3, that would be right here. If you're asked if that's a solution, you want to say no, and the reason being is it's not in the shaded region. So shaded means solutions, non-shaded means they're not a solution. So I wanted to take you very quickly through just a quick recap of how to graph and shade. What we're going to do now is we're going to graph 2 problems in one. So we'll go ahead and graph our first function, 2x minus 3. So we're going to start down here at -3, and we're going to go up to over 1. And then you want to decide, should that line be solid or dashed? It is underlined, so it's going to be solid. So we're going to go straight up here. And that one is done. Now typically what we would do then is we would shade. So if I put my pencil in the middle, less means to lower, I would start my fire over here on this side. I don't want to do that this time, and the reason is because I'm not done. I have to graph a whole nother function. So what I'll do is, instead of starting a fire, I'm just going to draw a shape. Any shape you want, it doesn't matter. And what I'm going to do is I'm just going to spread my shape down the line, just so it's very obvious to me what would the shaded side be. So it would be that side of the line. So then we're going to go ahead and we're going to graph the other line. We're going to start at 2, and we're going to go down 3, right 1. Now this time it's going to be a dash because it's not underlined. So we want to dash that line. Okay, now you're going to put your pencil on your line. Got to decide which side we get shaded. And because it says greater, we're going to raise our pencil up a little bit. And this time I want you to draw a different shape. So something maybe like stars or hearts or something like that. And I want you to just let those stars travel all the way down your line. Just like that. So the idea is, when you go to shade, right, and this is why we didn't go ahead and shade anything yet, you have to pick the region that has both shapes in it, that makes both inequalities true. And just to give you an idea, now don't do this on your paper, I'm just going to show you this region here so that you can see what I see. Right, this right here, that represents a region. You'll notice there are no circles in this region, there's only stars, so that can't be the answer. It's got to have both shapes in it. Now if you look at this region right here, you can see that that's going to have circles and stars in it. So that's the region that you want to go ahead and shade. All right, so if you have not, go ahead and shade that right now. Any point in that region would count as a solution. So when we do that, we call that the solution region, and any solution will be lying inside of that shaded area. So I'm going to use my graph and name 3 solutions. So let's go with 6, 1. We could go with 7, 3. We could also go with a point on the line itself, like 5, 5. That would work. See, that counts as being in the shaded region because it's actually on the line itself. But what's interesting is down here, you see this point right here, 0, -3. When I ask kids, is that a solution, I get 2 answers. I'll get kids that say yes, and I'll say why? And they'll say, because it's on the solid line, Mrs. Stoltz. But then I have other kids, I'll say no, because it doesn't touch the shaded region. So like, which one do you go with? So the rule is your line, whatever that dot is, that has to be touching the shade. So while this makes the black line happy, it does not follow the rules of the right or of the red line. It's on the wrong side of the red line. So that will not count. Even though it's on a solid, it's not within the shaded section. Okay, it's not a boundary to the shaded. And it's the same thing here. If I pick this order pair right here, it looks like 3, -5. It is touching the shaded region, but it's not going to count as a solution. All right, because it's on a dashed line. So in our next video, we're going to go ahead and graph 2 system inequalities.